This lesson is on area of a segment. There's another formula that will be useful to learn, but it's not essential that you memorise it, because I'm going to show you where this formula comes from, and if you understand that process, that'll probably be much more beneficial to you. So, if we let the area of a segment be represented by A, and in this diagram here, you can see a segment is formed by a chord. So here's the chord AB, and that is dividing this circle into both a minor segment and a major segment. Now the minor segment is shaded in yellow because that's the smaller segment, and the major segment is the bigger segment, and that's shaded in purple here. Now the minor segment is bounded by the chord AB and the arc AB. So we're trying to find the area of this minor segment. So the formula is found. You can see that this area of this yellow area is the area of the sector, which we found in the last lesson, minus the area of the triangle. So you can see here, here's the area of the sector, and then if you subtract that area of the triangle, you'll be left with this yellow area, the area of the minor segment. So the area of a sector, that is a formula that you need to memorise from last lesson. That's half r squared theta, where theta is in radians. Now the area of the triangle, you can find an area of any triangle using half AB sine C. Now in this particular triangle, what is A and B? A and B are the lengths of these two sides, which happen to be our radius. Right here. So instead of AB, you can actually have r times r, which is r squared. So you end up with half r squared theta minus half r squared sine theta, because C is this angle in the middle of the triangle, which is also theta. If we factorise out half r squared, you see that we get the formula I've got at the top of the page. Half r squared times by theta minus sine theta. You just have to remember that using this formula, that the theta is in radians, because that's what we had for the last lesson. Area of the sector formula, theta was in radians. Okay, examples. The first example, in a circle of radius 12 metres, a chord subtends an angle of 135 degrees. So, radius of 12 metres. So not the best circle, but there's our radius of 12. Chord subtends an angle of 135 degrees. So here's our chord, and that is subtended by this angle of 135 degrees at the centre of the circle. Find the area of the minor segment cut off by the chord. So we're trying to find this area in here, this area of this minor segment. Give your answer correct to point to one decimal place. Okay, so now remember we need our angle to be in degrees. So let's change 135 degrees to radians, and we do that by timesing by pi on 180, and that will simplify to 3 pi on 4. Okay, now we can use our formula. The area of a segment is half r squared theta minus sine theta. So it will be half 12 squared times 12 squared, and our theta is 3 pi on 4 in radians, minus sine of 3 pi on 4. Now making sure your calculator is in radians mode, you should get 118.7 metres squared. In the next example here, in this next example, AB is a chord of length 6 centimetres in a circle centre C of radius 4 centimetres. Find the size of angle ACB. Okay, so if we let angle ACB equal theta, the way that we can find this angle is using the cosine rule, because AC, being the radius of the circle, is also 4 centimetres. So we can say cos theta equals 4 squared plus 4 squared minus 6 squared all over 2 times 4 times 4. And then if you have your calculator in radians mode, you type that in and press Shift Cos, and you should get 1.696 radians, rounded to 3 decimal places. But save that angle in your memory, so that you don't get a rounding error in these later parts of the question. Okay, so that's part A. Find the size of angle, ACB. Alright, part B. Find the length of the minor arc AB. The minor arc. This is this section here. And you learnt the arc length formula. L equals R theta, where the radius is 4. And theta we just found is 1.696. But using the full value stored in your calculator, and you should get 6.8 centimetres to 1 decimal place. Alright, part C. Find the area of sector ACB. Sector ACB is this whole sector, the piece of pizza, piece of pie. Alright, so that sector, the area formula is half r squared theta. Alright, so we got half times the radius squared, radius was 4, times theta, which is 1.696. And that area then will be 13.6 centimetres squared to 1 decimal place. And then the last part of this question asks us to find the area of the minus segment. So the minus segment, I'll just colour in yellow again, sticking to our theme of colouring in the segments yellow. And I might change to purple. So, the area of the minus segment cut off by the chord AB, the area formula, well, it's going to be, the area of that sector minus the area of the triangle. So the area of the sector is that, and then minus the area of the triangle. So we've got half times the radius, which is 4 squared, times 1.696 minus sine of 1.696. And you should get 5.63 centimetres squared to 2 decimal places. Okay.